Hello, welcome to this organic chemistry lab video. Today we're going to talk about simple and fractional distillation. Let's begin by talking about some theoretical aspects. First, let's just imagine that you have a pot on top of your stove and you fill it, let's say about halfway with water, like you're going to make pasta or something like that. If you supply heat to the pot from underneath here, eventually the temperature of that water is going to increase and increase and increase until it reaches about 100 degrees C, which is the boiling point of water. At that point, particles are going to start going from the condensed liquid phase into the vapor phase. They're going to start coming up. If you have a lid here, you're going to see droplets form. And eventually it's going to become a rolling boil where the big bubbles here, droplets are coming up here, they're condensing at this point, and then the drops are coming down as well. So we have this upward vaporization and then a downward condensation. And whenever we're at boiling, that's going to be an equilibrium between condensed phase and vapor phase. So for distillation, we're going to be collecting the distillate. So the distillate is the vapor phase as it's being formed. We're going to collect that, and so distillation is a very important technique for purifying compounds. So we have these little Hickman stills that can purify less than a milliliter of material. And also you can imagine those giant distillation towers that you may have seen pictures of in petroleum refineries. So tons and tons and tons of material can be distilled. So down here is an illustration of a simple distillation apparatus. We have our initial liquid right here, and distillation is valuable for probably the most important or the most common use of a simple distillation is to purify a liquid from some material that's going to remain solid. So if you have some material that is dissolved in that liquid and it's solid, at the end you will get the liquid over here and the solid particles will remain. But you can also use this method or the fractional distillation method to separate two different liquids, and that's going to be what we do in this lab. So we begin with the liquid here. In our lab, we're going to have a 50-50 mixture of two different organic liquids. And as we start supplying heat to the system, we're going to have particles going up in a distillation, and then particles also, in a vapor phase, and then particles also condensing. So you're going to start seeing little drops forming here at first, and with continued heat, those particles are going to reach their way up here, and they're in the vapor phase. Eventually, they're going to hit the thermometer. Once they hit that thermometer, those particles are in the vapor phase, so they are at the boiling point. We're going to see that thermometer temperature start shooting up from room temperature to whatever the boiling point of the liquid that's coming off is. And then gravity is going to cause some of those particles to come down here. And right here we have a cold water condenser. So if this is cold, we're going to have that right about the temperature of water and ice, about 4 degrees Celsius. And that vapor phase is going to condense in here. So this is called a condenser because it condenses the vapor phase back into the condensed liquid phase. Then we're going to have liquid particles that just pour down here and drop and start filling up this side. In our setup, we're going to have a graduated cylinder here, not a round bottom flask, but the same idea holds true. For the fractional distillation, right at this point, instead of connecting the round bottom flask directly to this three-way adapter, we're going to have something called a V-grow column, and I'll try to draw that here. These are our little ground glass joints that connect everything. The V-grow column, and you're going to see it in the video, has all these little points going inward. And all that does, it increases the surface area. And the more surface area you have from this point right here up until this point right here, the more vaporization, condensation events can occur. And the more of those events that can occur, the better the separation between the two liquids will be. So the V-grow column right here that V-grow column is going to increase the amount of condensation, vaporization, equilibrium events that occur as the liquid travels up and gets condensed in the condenser. So it's going to increase the ability of the distillation to separate those two liquids. So in this type of a graph right here, we're looking at the temperature of the distillate. Now that will be the temperature that's being recorded right here. That's the temperature that's being recorded right here as the distillate comes up, interacts with the thermometer, and then comes over to be condensed. Comparing that temperature as a function of the total volume of distillate. We're looking at a 50-50 mixture of acetone and cyclohexane. In your mixture, you're not going to know what your mixture is. You're going to have to determine that. But in this mixture, this is what we're doing in the video. And it's 30 milliliters total. So 15 milliliters of acetone, 15 milliliters of cyclohexane. So let's imagine, what would a perfect distillation look like? Imagine that you're able to separate out the acetone, which has a boiling point of 56 degrees Celsius, and separate that from cyclohexane, which has the boiling point of 81 Celsius. What would this look like? What's really important to note here is that this x-axis is not time. It's the volume of the distillate. It's based on the volume. If it's a perfect distillation, we would see no temperature change. We wouldn't see anything happening. And then eventually, once we start getting that material into the vapor phase and interacting with the thermometer and condensing, we just see all of this 15 milliliters being collected. It all gets collected all the way up to the boiling point of acetone. And then it just hangs out for a while in terms of time. So we see no more drops coming off. And then eventually we start supplying more heat, and then we end up reaching the boiling point of cyclohexane. The cyclohexane comes off, and then that just carries on all the way until we get all the material off. Well, it turns out that when we do this with a simple distillation, we usually don't get a perfect separation unless the boiling points are very, very different. So in a simple distillation, we expect to see mixtures of material distilling. And the way that that's often going to look is something like this. It might be somewhat linear, or it might be kind of a shape that has a little bit of an S curve to it. Something like that. So that will be our simple distillation. Usually that's what we see. But you might get it might look more like the green line. It depends on the system. But it would look more like that. What about the fractional distillation? When we do the fractional distillation, remember we have that V-grow column. That allows for a much better separation because of all that surface area. It allows for a lot more of these vaporization, condensation events to occur. So in a fractional distillation, that's going to look more like the perfect distillation we have in green here. At least that's our expectation. It's not going to be perfect, but ideally it would look more like that green line. So the fractional versus simple distillation should have plots that look like this. And the more S-shaped this is, the more it represents that green line, the better your separation will end up being. There's a French term that chefs will be well aware of called mise en place, everything in its place. Before you begin cooking a meal, you should have all of your cookware ready to go, all of your ingredients ready to go, out and easily accessible before you begin. We should do the same thing whenever we set up an experiment. Here is all of the material that we're going to need for today's experiment. We have a 50 milliliter round bottom flask, a 3-way adapter, a thermometer adapter, a thermometer, a condenser, a vacuum adapter, and then a 50 milliliter graduated cylinder, 10 milliliter graduated cylinder. That's the glassware. We will also need a small clamp, a larger clamp, some boiling chips, and then finally our heat source, which is going to be this thermo well right here. And there is an attached variac right there, which will control the power to determine how much heat is provided to the system. Now we are ready to set up our experiment. What we're going to do today is separate a mixture of 2 organic liquids. Right here we have 15 milliliters of one compound, 15 milliliters of another compound. When you were going to run this experiment, it would be unknowns. You'd have to figure out what they are. But I'll let you know what this is. This is 15 milliliters of acetone and 15 milliliters of cyclohexane. We're going to separate these by both simple and fractional distillation and compare how well the 2 distillation techniques work. Let's begin now by setting up our apparatus. I have the clamps already in place and ready to go. I have a lab jack here that's going to allow us to adjust the height of the thermowell. And right here is the variac. That will be what controls the amount of current that enters the thermowell, which is directly related to how much heat will be provided into the sample. Very important, do not plug that in yet. If you plug that, as soon as you plug that in, it starts heating up. Also very important, make sure you have the variac. If you directly connect the thermowell to the outlet, it's going to get extremely hot extremely quickly. So we're not going to plug that in yet, we're going to begin. Something I see students do all the time, they set up all the glassware, but they forgot to put in the boiling stones. I have a few right there. We want to put those in before we begin. And they forget to put their sample in. So let's start with our small clamp, connecting our flask that we will be using for our distillation to a vertical post. It's very important that we use a vertical post. If there's any sort of adjustments here, if it gets moved, it's just going to go to the right or to the left. If we use a horizontal post, it can go up and down, causing our mixture to spill out. That would be a big problem. So this is connected right here, and I'm going to take this out to show you. It's extremely important that it's connected with a small 3-finger clamp where this finger of the clamp is directly under the lip of the flask. You don't want to have this connected any other way or it won't be stable. This right here is the stable way to connect that flask to a clamp. All right, at this point we should put in our sample. I'm going to go grab a funnel. There's a funnel. Here is our mixture. I'm going to pour all of that in. All right. Now we're ready to set up our apparatus. The first thing, the three-way adapter goes right here. By the way, this is the simple distillation, not the fractional yet. And then we're going to put in the thermometer adapter. So the thermometer adapter is this cylindrical piece, has this ground joint. These glassware pieces all sort of fit together like Lego because of their, they have these ground glass junctions, 1420 junctions. We're going to slide the thermometer inside here. Be careful not to really jam it in. You could break, so just ease it in to about there. Now the height of that thermometer is extremely important. We want the thermometer, the bottom tip of it, to be right at the same line as the bottom of this part of the three-way, oops, I went a little too high, this part of the three-way adapter. That's really important because we want to read the temperature as our distillate is coming up and going over to the condenser. All right, now we will use a condenser. This is going to be the piece of glassware that has it provides cooling to the system, and it takes that distillate in the vapor phase and condenses it back to a condensed liquid phase. If you haven't seen a condenser before, it's really important to kind of consider how this looks. There's an interior tube, and that connects, if we look this way, it goes right through here, right through the tube. Then there's an exterior jacket. That exterior jacket is where the water will flow. We're going to flow water through one of these inlets and then out the other inlet. We're going to talk about which one goes, which way the water comes in just a second. So first we connect it. Now we're going to use one of the Keck clamps. That Keck clamp is going to hold this in place. Now you may be tempted to put a Keck clamp right here. Do not do that. If you put a Keck clamp here, you will screw up the way that this clamp is connected to the flask. It will actually weaken the connection. It will make it more likely to come apart. So no Keck clamp here, just the exterior clamp. But there is a Keck clamp here, and then we're going to put our vacuum adapter. Now, for some distillations, you would want to use vacuum if you have a high boiling point. We don't need to use vacuum today, but we're going to still use this adapter. Let's ignore that beeping. So then we're going to use that adapter right here. And now this is where that larger clamp comes in. This larger clamp is just providing some support for this part of the system to prevent any glassware from separating. So this junction right here could separate because of the weight of this part of the system pushing down. But if we keep a clamp here that's pretty loosely connected, we don't want to have this really tight. If we have it really tight, it could cause things to separate. Just loosely, just kind of taking care of the gravity, holding things up. You want this whole setup to be high enough that your 50 milliliter graduated cylinder can fit underneath. Now you're going to begin taking measurements with a 10 milliliter graduated cylinder. Now you are living dangerously if you just set it down there. So you can take a beaker, put it upside down, and then connect set up the graduated cylinder in this way so that our drips come down. Just to make it completely clear what we're doing here, as we start boiling this sample, vapor is going to come up here, it's going to come over, condense, and then it's going to drip down into our graduated cylinder. And we're going to be taking notes at each 2 milliliter increment. What is the temperature reading right here? Now we still have one thing left to do. We have to connect this condenser to the water source. So I have a question for you. Should we have the cold water flow in from here and exit here? Or should we have the cold water flow in from here and exit here? What do you think? Well, we're going to want the cold water to enter from here and exit here. The reason is, as we come up from the bottom, gravity will cause all the liquid to stay and fully fill the jacket before it leaves. If we had the cold water enter from the top, we would just have a river at the bottom here flowing out. So let's connect that water source. The way we have this set up is that the red tape indicates the exit where the water is going to leave. So I'm going to set that right here. Connect it to that point. And then the cold water coming away from the pump has a blue tape that's going to be connected right here. Now you want to get that on there nice and tight. If you feel a lot of resistance, don't force it. You don't want anything to break, especially anything that's glass in your hands. You don't want that to break. So you connect that, and we're ready to begin now. Something you want to be really cautious of, these are plastic tubes. When you lift this variac, or not variac, thermowell, you want to make sure that that tube isn't touching. This can get really hot. That's its job, to get hot. So you want to bend the condenser inlet away. Because if you melt that tube during the distillation, you're going to have a big flood. All the water is going to go everywhere. It's going to damage the tube. So we're just about ready to begin. What I'm going to do now is lift this thermowell. I'm going to move the camera so we can see this a little bit better. We're going to lift the thermowell, and we don't want this to be really forced up against the glass, but you want the bottom to be just barely, just there. It just started to touch, just barely touching. I'm actually going to go down just about a millimeter. We don't want to be forcing those together to create any stress in the glass. Okay, now we are ready to begin. I have our thermowell. I'm going to set it to our variac. I'm going to set it to about half strength. We'll see what that is. Be sure to put the graduated cylinder here. I'm going to start the heat. So I'm not going to start the heat right now. I'm going to turn on the water flow and then start the heat. So here we go. Now on this side of the fume hood, I'm going to set up our fractional distillation. It's going to be a very similar setup, except we're going to use this Vigro column. So this Vigro column is going to go right above the flask that is undergoing the distillation. So it's going to go here, between here, and then up here will be our three-way adapter. So the Vigro column is a long cylinder that has these little points that go inward into the cylinder, these nooks and crannies, if you will. All this does is it increases the surface area that the distillate must move through before it goes up here and eventually over into the condenser. That increased surface area increases the number of vaporization, condensation, condensation events that the distillate must undergo as it passes through. So this will allow for better separation. Hopefully, at least that's what we're expecting to see. So I'm going to set up that distillation apparatus right now. We're using the same mixture of liquids that we used over there in the simple distillation. In this setup, we're going to use 2 extra ket clamps that we didn't use in the simple distillation, right here and right here. That's just going to make the whole setup a little bit more stable. Okay, now we have our fractional distillation set up. You want to be cautious with the fractional distillation because it's a bigger setup, it's a little bit wonky, but if you put this clamp over here, everything should be nice and static and ready to go. Now we're ready to start our experiment. Well, that wraps up this video on how to set up your simple and your fractional distillations. In your experiment, you're going to be really careful to measure the temperature of the distillate at each 2 milliliter increment of distillate as it comes out into the graduated cylinder. But for this video, just wanted to show you the setup and things to look for. Once this is all cooled down, I can clean all the glassware just by rinsing with some acetone into the organic waste. Also, in your experiment, you would check the effectiveness of the separation using gas chromatography to see how much of each component is in each of those in the fractions. But this is being recorded during the COVID crisis. The GCs are not up and running right now, so we will skip that as part of this video. This concludes our video. I look forward to seeing you next time in an organic chemistry lab.